Hello there. Oh man. Oh, I installed a new firewall on the machine because the Windows one is so useless, and this one is free. I would pay for the full version, but I can't. But now it has, see, what it has is this thing. I want to fix it. Damn it. I want to keep that setting off. See, about that. This. If I could click this, you're not allowed to unless you pay. I would leave it on during a recording like this. But now, opened or saved. Now, see, this is constantly saving a file and already using up most of the processor. So I've got to turn this off during the recording part. I'm going to get a message. It's going to get mad. I'll turn it back on later. What happened was, it was very strange. My downloads were very slow, and I was already getting suspicious. And I noticed, like if I tried to download a video from YouTube, right, even one of my own videos, the data rate would be like 12K per second or something like that, right? But if I downloaded something with BitTorrent, it could go as high as 300-400K or higher. And then I did this netstat. I just wanted netstat, right? Now you see it's got a couple of things here. Well, this is 55 lines high, and it went through about 3 or 4 pages of connections, okay? And BitTorrent wasn't even running. And one of the other things is, I had already, just as an experiment, tried blocking BitTorrent with the firewall, and it wouldn't block it. It connected just fine. No problems whatsoever. And so that got me to thinking that maybe not the program BitTorrent itself, but somehow once those peer-to-peer connections are made, there's some kind of loophole that allows them to stay active, and so people can continue downloading things from the machine, and they can probably browse the machine. And then I ran the Process Explorer, and I found that the indexing service was very, active. I checked around, and I looked at all the things that it was indexing. Like one was, I have a directory called movies. I haven't watched a movie in like 3 months. High priority index directory, and another program files, right, and Windows, and all of these things. And so I essentially just turned off all of the. I turned off, or I don't know how to turn it off. You can't turn it off, but I unclicked every directory that it was indexing, and I think that's where the loophole is. Because all those connections began to die. Everything was on time wait, and eventually they died. But I don't trust the Windows built-in, the virus protection and the firewall. And I had deliberately excluded BitTorrent from working, both in the firewall and in the program. I told it not to add an exception to the firewall, and it was working fine. In fact, I'd started up and I'd already have 300 connections. immediately. So I don't know. Now I'm okay. I never get anything more than this sort of thing, unless it's growing. So even lost some. And I ran BitTorrent before. Anyway, that's not my point. The point is where to start. One place to start, actually, I was thinking about this like hardware exception, and I was looking at when this whole idea was initially introduced. It was with the 386 back in 85, I guess. And I went to fix something, in here. So where did it say that? I was trying to find something out about hardware, like hardware support for debugging, and sometimes people, you see, that's fine, right? That would be fine, but what would not be fine if this was, two words, floating and point, not related. And there's something like that in here. Here. Offered support for hardware, open a new tab. Computer hardware, debugging, open a new tab. So we get computer hardware, yeah, we know about that. Heard of that, mouse, keyboard. Debugging, yeah, debugging, we debug a program. But that's not what that reference is supposed to mean. So I went to try and fix this, and I did a search, and I came up with a bunch of pages. And again, I couldn't get through the various pages, but they did come back. I have them here. But I don't think this, I think, is probably the closest wiki match I can find for hardware debugger. This is introducing with the 386. That's why the 386 is mentioned here. The other one that wouldn't come up before was this. This is like the theory behind what they call it, virtual machine, or virtualization. Another type of abstraction layer. In the case of the 386, that virtual computer. But along with the support not only for the virtualizing of for having virtual computers on a single computer, like essentially emulators, came these debug registers, which is something that one can look at when a debug exception handler gets invoked. See, we can have a look at these later. Now, I just want to fix this. I want to put that link in instead. The problem is where to begin. T6 for that? Everything else. It looks fine. I forget what it looks like now. Real mode. Oh, here it is. No, computer virtual memory. Hard. This is it. Computer hardware. We don't want that. Well, how do I just do a regular link? I forget. Okay. This says computer hardware was the link that it went to. Where is that listed up here? I mean, it wasn't in that format. Oh, maybe a space is always an underscore, something like that. Yeah, we'll try it. Now I gotta find it again. Where are you? What I want is this. I wonder why the word gets split. Does that look right? It's preview. I didn't sign my name. My preview for. No, that's right. That's what I want. And how do I do that again? Wiggle, wiggle, wiggle. Here. Or here. Or here. You know, I gotta put it somewhere. Double link. No, that's not. I would say it's a minor edit. Preview it again. See what happens with the wiggle. Now, is that going to show up? Oh, I guess it's the same. Normally it shouldn't. I don't think. If I wasn't signed on, I don't think I would see that. I hope. Or I could have. No. Well, I could have put it inside the bracket, maybe. Okay, that takes you to something to do with hardware debugging. for the 386. You know, I'm just thinking about the 386 and see how much time I've already wasted. Not too bad. And a bit about the history of it. I was looking through some of the historical stuff. You know, when I first went to university, it was in 1984, I guess. 80, yeah, I think it was 84 to 88 for my undergrad. We had a mainframe computer there, and there weren't really any. The idea of the PC computer didn't exist, so it had to be around that time. When did the PC first come out? This is 85. But it was right around the same time, too. I wasn't aware of what was going on with that. Introduced in 85. The only kind of computers that a person would use would be a calculator. And you had programmable calculators. I had one. I think it was made by Sony when they used to do electronics instead of now they're fully employed in running lawsuits for music copyright infringement, which is the most lucrative business going these days. So when they used to be productive, they used to make things like calculators, and you could program it in the sense that you could write in an equation, like let's say you put in minus b plus or minus square root b squared minus 4ac, to get the roots of a quadratic. What's the name of that stupid thing? I wonder if code calls is working. I think they have it on a one click thing. You get it. Like they have predefined. They have a set of predefined equation favors, algebra. Oh, I have to make my own. Here, no. That's my favorite. Come on. Type your equation. No, frac. Oh no, before that. Minus. It's the B on the, no. No, I can't do it like this. I need to go back. How do I get back to the thing where I can choose something? Oh, X. Oh, examples. Here we go. Oh, that's what that was. This one, what is the formula? Minus b plus or minus? Where is that? Here. Almost first one. Plus or minus. B squared Oh, square root. SQRT. Let me back up, so sorry. Square root b squared minus 4ac 2a. Is that right? Shouldn't the b be, well, we can always test it. Square root b squared 4ac. I wish it wouldn't put the double things in bracket, square, oh, no, sorry. Okay, let's see it. Fraction, square root, b squared minus 4ac, that's closed. That closes that. We must see it. Okay, one at a time. I can't believe these things. I don't want to download the image. View image. F5. The SQRT is on. I think it probably is. Square root. Do you see a square root anywhere? There's powers. There's fractions. Another thing. Oh, come on. Where are you? Here it is. Ah. Huh? Just do it like that. Now I lost it. Here it is. B. Adding to the pole. Alright, okay. Right. You don't always need a curve, eh? Oh, it's just not showing me anything. Ah, well, too bad. Anyway, you could type in an equation like that, right? But you can only put one in. It was sometimes handy because if you had to do the same thing over and over again in an iterative way, then you could do that. But you couldn't save them, and you couldn't have more than one. But of course, there was a my second year group. I remember now that there was a computer. Besides that mainframe, there was that was for the whole university, very expensive. In my, either second or third year, one of my classes, we were given access to these mini terminal computers where you could program in BASIC. And I guess, I don't know what those were called, but those were the beginnings of home computers. And it's interesting, if you look at the history of it, and I was looking at it with I added some new features to my Notepad program. I was looking at some of the history things, like the first thing, the 8086, that was the first PC computer, which I never saw till after those years, was essentially a toy. And the roots of that toy go back to this company called Datapoint. Of these two guys working for NASA, well, they were they were working for this company, GDDD, in Florida, and were contracted out by NASA as part of the moon mission, the Apollo mission. And of course, they had to work on these mainframe computers. And they came up with this idea of developing, instead of using these noisy teletype terminals. Here, I'll show you the page. I think they started a company called Datapoint, or CTC, which became Datapoint. Okay. Yeah, Foundation Datapoint. These are the guys that actually invented the microprocessor, turned out, by accident. Well, not by accident really, but what they wanted was that they were tired of typing in a teletype terminal. I don't know if you've probably never seen one. I don't remember seeing one. If they have a picture of one. They're really clunky, noisy things. They, the buttons are. See, you push, you have to push. It's like a typewriter. It is essentially a typewriter, but as you push the button, it makes electrical contacts, and so therefore you can enter code in like you would with a punch card to go into the mainframe. But they had this idea of making a kind of thing that didn't work that way, but used a television screen. You'll notice there's no screen here, right? It's a typewriter, and all you see is something on a piece of paper, which I presume would have been a punch card. But that was also around the same time. Let's see, what year is this? Well, it's before that. I'm not sure how they would have converted their thing to punch cards, but on the advice of one of his tutors from UT, they decided to develop a quieter and smaller input device, just for input, using a television set screen. So at least, okay, here it is. Maybe it makes a punch card in here or something. I don't know how you get the data into the mainframe, because when I first showed up at the university, they were still using punch cards. So that was they just stopped using punch cards. And that would have been 83. And we're talking about 1960s. But, you'll notice here that there's a magnetic tape disc wheel. And you can take one of the point of the punch cards was for you to be able to get data onto one of these discs. So I guess it would just write directly onto one of those discs. Well, it's not a disc. It's like a very large cassette tape, right? Very large, large as in the steering wheel of your car, that kind of diameter. Okay, so that if they wanted to make a new input device based on a television set, and and it was an immediate success, okay, because what they did was they based their thing on the Texas Instrument chip to do the electronics, and it was a big hit, but they couldn't keep up with the orders, and they had no money. The chips were unreliable, it was a big problem. But somehow they raised $4 million by IPO. And so they outsourced to a whole bunch of local manufacturers the various bits and pieces, including a motorcycle helmet manufacturer. And so once in production, began co-sourcing chips from both Texas Instruments and Intel. And this has a funny ending too. This Texas Instruments and Intel eventually get into a legal dispute over who invented the microprocessor. Anyway, so it sold pretty well for a while, right? Then they decided to make one that was a little bit more intelligent. But there was only one way this thing could work, right? But they wanted it to be a little bit configurable. Now, you have to remember, I don't know about this date, but in my time, which is 80s, all of the fancy stuff that comes with today's major processors, which started after the 386, was already there, and it was already the designs and theory were done. I mean, one of those mainframe computers has, protective mode and virtual machines and paging and all that stuff, or at least did. But you would never be able to afford one. I worked it out, in fact. The VAX, which was what I used at McGill University during my graduate course, I worked it out in today's dollars. What it would have cost you. Now this is what you would call not a microcomputer, but a mini computer, which is not it's halfway between a mainframe and the VAX. So instruction set by Deep Deck in the 70s. It had memory paging, protected mode, multitasking, virtual addressing, and everything in the 386. But it would have cost up to $1 million for the system. And the system was based on what people thought computers were. They thought a computer was a big machine that sits in a room somewhere. And then there were a bunch of terminals connected to it. But these guys decided to make an intelligent terminal. And they produced the underlying architecture of the modern microprocessor on a living room floor. Now this is where I heard that Schmidt name too. That's probably why I thought he was the same Schmidt as the other. It's not different Schmidt. They pitched the idea to both Texas Instruments and Intel to develop what eventually became the 8008, which is as it says here, the forerunner of the microprocessor chips found in today's personal computing devices. Everywhere. You found in your telephone, in your ThinkPad or whatever, everything. Couldn't keep up with demand, blah, blah, blah. But the one funny bit I found in here was how they named it. What is this? What is it? I have it in my notes. Yeah, this is how it goes. Let me just try and find the other thing first. Okay, they had a dinner date. CTC was the company they initially started, which was going broke from all of its loans. And it's Ray and Ross, the two guys, arranged dinner with the president of Intel and the president of Texas Instruments, having pre-drawn the schematic for the microprocessor on 2 postcards, and gave each, so that 1 postcard, 1 processor. The microprocessor, the idea of the microprocessor is a computer on a single chip, right? Which had never been done before. But they worked it out on the living room floor and just drew it out by hand on a couple postcards and then made a bet. The first company to build a computer on a chip would forgive Data Point their outstanding invoice. And that would have been I guess Data Point was part of CTC. That would give them a real break, right? They were really highly in debt. It was eventually Intel that went ahead and did it, and came up with the world's first microprocessor, named after the CTC's first invoice to Intel for the chips. So the number 8008 was the number of the invoice. Now, this is the funny ending, at least that part of it. In later years, after the death of Phil Ray, there were the two, right? Ray and what were the other one? Raj, Gus Raj. His widow, Ray's widow, and dinner guest, this person, Brenda Ray Coffey, was deposed by this law firm, TI, when TI and Intel were involved in a lawsuit as to which one invented the microprocessor, right? Presumably, well, obviously, Intel must have been claiming they invented the microprocessor, but all it would have taken would have been the presentation of one of those postcards as evidence in court that neither company invented the microprocessor. It was invented by John Phil Ray and Augustin Roth. They invented the microprocessor, and it was developed by Intel, sure, but Intel couldn't claim invention of it or patent it. Anyway, that's kind of a funny history. Now how much time have I wasted? Wasted a lot of time. But you might want to have a look at this and just see how this all developed. And eventually the 386 came along. I think the world today would look not much different from the world of the 1970s if it hadn't been for that toy that those guys made. Remember that this thing, the data point thing, was designed as an input device. That's it. But a programmable one, so that you can make the background green or something. However, some users of the terminals chose to use them as programmable computers. And if you think about it, you had the companies that were making these great big computers, designing the software and the operating systems and everything. All of that work was in the hands of maybe a few dozen engineers, right? But these terminals didn't cost anything. So anybody could go to the store and buy one and have a computer at home, right? Sure, it's a toy. But now you're talking about millions of people, amateurs, sure, working on computing problems, right? And coming up with solutions and solving the problems that couldn't be solved, I don't think could have been solved by a few dozen engineers in that amount of time. Simply because the access was universal. Everyone could have a computer. It wasn't a mainframe. It didn't have a protected mode or anything. And that's probably best, because the people that did all the work wouldn't have had the background to understand all of the fancy jargon. I never figured out anything about the backs. I used a terminal, and I wrote programs according to the languages you could write in, Fortran. Now you have a thing where people could write their own computer languages, right? Anyway, now along comes the 386. And that just changed everything. And that's when the toy joined the family of nations, like the mainframe and so on and so forth. It went from being a toy to being a real computer. It now has, at this point, support for virtual addressing, paging, all of the things that it had existed in these supercomputers, but were inaccessible to the average person. I mean, the 386 came out as a commercial product, right, for a consumer, not as something to be sold to a corporation. And Microsoft had Windows. Windows 3 was based entirely on the old segmented 8086 model, and the next version, 3.1. Well, no, I guess it used some other stuff. There was some protected mode stuff coming on in 286. But in the 3.1 version of Windows, a couple of the people at Microsoft figured, well, why don't we use some of these features of this chip and see what happens? The claim is everything should still work the same. So they decided to make to create. You have to set all this up. Setting up protected mode is a long job. Like just stepping into protected mode is about, some 1,000 pages of code to set up all the various bits and pieces you gotta set up. But not that much. To set up an environment for a protected thing called a virtual machine, and the Windows kernel, or whatever you want to call it, win.com was a program that you would run, ran as a virtual machine, because the processor supported it. It could be a virtual machine, and so it could take advantage of all of the things that are accessible to a virtual machine, which means that it's oversight. There's oversight, right? There's protected memory. There's hardware debugging, and there's a possibility of having more than one virtual machine. Once the processor is in virtual machine mode, you can create another virtual machine. And the little DOS boxes that came up that looked like these were also virtual machines, on exactly equal footing with the Windows virtual machine that looked like this. So people didn't think of it that way. If there were 3 DOS boxes and 1 Windows, only a quarter of the processor time would have been spent in the Windows environment. This is no longer, but it may be a virtual machine. Everything's a virtual machine now. Right? Every process is a virtual machine, and a special type of virtual machine. That's why all your programs have they're all the same address, and all the registers and everything are all the same. Everything is exactly the same for all programs, because everything's been virtualized. Right? There's no meaning to it. The numbers have no physical meaning. Anyway, so we're going to be talking about the kinds of things that this processor can do, and its descendants. The Pentium is one of them. It can hardware exceptions may occur, and the operating system at the next level up can halt that machine and invoke special code to essentially ask the machine what it intends to do about this particular error that might have occurred, and that's also a long story. But the historical story is pretty close to what I've been talking about. Getting there such that you have one in your home, and then playing with it, which is what we'll try and start doing in the next video. Okay, well, I'll put this in the random chit chat box. Well, maybe not. Okay, see you.